I think we have covered this topic a lot today, how important data engineering is. So it's like, what else I'm going to add? But I came all the way over from India, so I'll just get on with that then. In the early sessions today, we discussed a number of customer challenges, and we also saw how AI and ML, generative AI, agentic AI, large language models, etc., were used to build solutions for them. But for any of these solutions to actually work, there's a lot that needs to happen in the background. It is not just about the algorithm or the model. You need the right data in the right format, properly modeled and transformed. You need data that is accurate, reliable, and trusted, so that the outputs from your AI solutions are also accurate, reliable, and trusted. This is where data engineering and governance comes in. They provide the foundation for everything that follows. Without good data engineering and governance practices, even the best models can fail. In today's session, we are going to cover some of those practices. Before we dive deeper, I want to cover some engineering fundamentals. I'll start with the medallion architecture. To put it simply, it's a way of organizing and transforming data through different layers or stages of readiness. It's a logical design pattern that can be implemented on most modern platforms. You have heard terms like bronze, silver, gold. This is just one way of describing the layers. Some organizations use terms like raw, processed, curated. It's all the same idea. We start with the bronze layer. That's where unprocessed data comes directly from the source. And then in the silver layer, we clean the data, shape it, and generally make it more usable. Finally, the gold layer, that is where the fully refined data sets, ready for use by your AI and ML models or in visualization tools or any other downstream applications. ETL pipelines move data through the different layers. So your Databricks workflows, Azure Data Factory pipelines, they extract, transform, and load data, which is basically saying copying data from the source, cleaning it, shaping it, generally to meet your business specific needs. We have talked a lot about data, but what exactly is data? It's not just rows and columns anymore. Everything is data. And that is one of the biggest advantages of AI and Gen AI. It allows you to treat everything as data. Images, audio files, PDF documents, even any kind of unstructured text like logs, call transcripts, all of these contain information that we can now extract and use in our processes. Of course, with a wide variety of data, we need specialized techniques to sometimes handle them. So if I take images, we might need to convert them into a specific file format before being able to use it. If the files are too large, we may need to compress it to a more manageable size. With audio, we often need to transcribe it to get the text. And sometimes we also need to clean up the background noise so that we can get a clearer output. With PDFs, we need to be able to pull the text from the right sections. PDFs usually have all kinds of stuff like charts, images, tables, and more text. So we need to be able to parse them separately to get what we need. Let's look at an example where we had to work with unstructured data. This is something that we are currently working on. At this customer, they have a large number of Power BI reports built over many years. But when a user has a need, are they able to find the right dashboard which can help answer that particular question? And this is not a unique problem. A lot of organizations face the same problem. Power BI, Click, Tableau, these different visualization tools have been around for years, and organizations would have spent countless hours of effort to build different reports. But are the users able to reach the correct report when they want? So how are we tackling this problem? Let's look at the final result first and then work backwards. This is a web app. The interface is quite simple. It has a text box where the user can ask their question, click on search, and then within a few seconds, we get a set of results. Now each result represents a page in a report, and it contains information about what the report can do. There's also a relevance score, basically how relevant this particular page is to the question that the user has asked. As a user, I can read through this description I see all seem relevant. I'll pick the second one. It opens up the report in the same web app itself. I can see there's a waterfall chart which shows the gross profit breakdown and how different components like gross sales value, discounts, and other costs have changed from this year versus last year. Seems like it's quite related to the question that I've asked. So now, if you have to build this solution, how do you approach it? The user asked a question. So maybe if we can, for each report, derive a list of questions that can be best, that explain what this report does. Maybe we can compare the question that the user has asked with this list of questions. So let's start by first collecting. I have a sample report here. We'll just first collect as much information from this report as possible. So I can see here there's a slicer for retailer at the top, and then some metrics around retailer margin, average margin, retailer share. The retailer share is 100% because I assume it's because none of the retailers have been selected. There's a bar chart comparing the retailer profit, actuals versus target for the key channels. There's a waterfall chart showing how the profit has changed this year versus last year for key sectors, product sectors. And then there is a bubble chart as well, which shows how the retailer profit growth has changed year on year, volume growth has changed year on year for each brand, and the size of the bubble refers to the sales volume. So I've been able to get a lot of information just by looking at this. Now I can get additional context by looking at the underlying data set. What are the different columns under the data set? Look at the different filters that is there. Is that sufficient? Maybe I could get more context by reaching out to users of the report. What are the situations that they probably use this report in? Are there some specific nuances that is not captured here? Something that will be useful for other users to find this report. So now I've been able to get all of these different distinct pieces of information, but this is just for one page in this report. And there are, at least if I take this report, there are 20 pages? And there might be another 1,000 reports in different workspaces in the organization. So there must be a better way on how we can collect all of this information. This is what we need to get to. A description of what the report does, the data sets, filters, and potentially any notes from the users as to what the report does. Earlier, I had used the rendering of the report from the web browser to get some input from that. So instead of that, I could very well use a screenshot of the report as a base. Now the screenshot, I can get it by doing an export to PowerPoint. And in the PowerPoint deck, I'll be able to see different slides, and each slide has an image of different pages of the report. But then again, I'll be back to the same problem, because there are 1,000 reports. How can I do export for each of the 1,000 reports? So that is where Power BI REST APIs come in. REST APIs are a programmatic interface that allows you to automate a lot of the tasks that you can do manually. So things like exporting the report, getting information about the data sets, getting information about the filters, all of this can be done with Power BI REST APIs. So we have a solution, but again, as with things, it is not as simple as it is. Running a Power BI REST API is quite a resource intensive operation, because sometimes, especially when you are exporting a report, you'll have to first render the report and then only export the report. So imagine if you have thousands of reports, and if you try running this REST API continuously for all the reports, you can easily overwhelm the Power BI service. So you need to bring in some techniques like potentially pacing out the REST API calls. And in case if you face some issues, maybe due to some memory issues or some timeout, pause and then try again later. Of course, we can't keep trying again. At one point, we have to log it and say, okay, there's an issue, and then move on to the next report. Once you have handled all this, we now have a screenshot of the report rather than the description of the report. We have information about the data sets, the filters, and for the annotations, we could use some forms or another web interface which will allow users to add any input that they want about some specific reports that they used. All of this information, we can now pass it to an LLM model. We discussed previously, LLMs can now help us process unstructured data and image is an example of that. So with the information that we have passed here, the screenshot of the report, the data sets, the filters, the LLM can process the image, look at all of this additional context, and prepare a list of questions that can be answered using this particular report. And now, when a user asks a question, we can use services like any AI search service to compare the user's question with a list of questions that the LLM has returned. And then we'll be able to find a list of dashboards that best answer the user's question. So this was quite simple, but then there was a lot happening in the background as we discussed. The process had to run through thousands of reports, and in case of any issues, handle it all without any user intervention. And this is what Andrew Ng, we talked about him before, was referring to in his 4 AI trends. Data engineering's importance is rising, particularly on management of unstructured data, text and images. And we just saw an example of how an image was used as a source to solve a specific customer need. Let's talk about some key principles that make all of this possible. First one, scalability shouldn't be an afterthought. Most AI initiatives, they kind of start small, often as a pilot, maybe for one geography or for one product category. But then when users start seeing the value of what the POC brings, there's often a need to scale. At that point, we shouldn't be trying to rebuild from scratch or building a separate pipeline for each geography. It might sound like, okay, that's common sense. But what we have seen is at customers, at a particular customer when we went in, we saw for a particular use case, they had a large number of pipelines. But when we looked at the pipeline, most of what the pipelines were doing were exactly the same, but for different market each time. Rather than doing it that way, just remove all the hard coding, have a single pipeline, have a parameter for the market, and then so we can use the same pipeline for different tasks or different markets. Of course, in some situations, some targeted development might be necessary. For example, for a particular geography, there might be some nuance that needs to be built in. So focus on that, but keep the base intact. And to this base, we can add additional functionalities like auditing, logging, data quality checks. All of this can be baked into the base. So the advantage is, tomorrow, if you roll it out to a new geography or a new product category, immediately all of these enhancements that you have built into the base are available for these new geography or new category. Next is metadata makes reuse possible. So this kind of builds on from the scalability point itself. Separate the logic from the configuration. So we talked about how we can use a single pipeline and have parameters to pass the information of the different markets or different product categories. So we can put all of this information into a single Excel file, for example, a metadata file, and use that as a base to pass on the parameter information to the pipelines. So recently at a customer, we had to move thousands of files between different layers. I think it was 13,500 odd. That's a large number of files. Now, we wouldn't be creating separate pipelines for each one of them. Yeah. So we had single pipeline and we had an Excel file. And in the Excel file, we didn't have to put the 13,500 entries as well. We had some of the key locations, the key file locations where these files were present, and some naming and some patterns for the names to recognize which files that we have to move. So now the advantage is tomorrow, if I have to say move data from another location, I don't have to touch the pipeline at all. I just have to make a single change to the Excel file, run the load, and in the next load, all the files come through. That is advantages of having a metadata-based ingestion framework. Next is building pipelines that bend, not break. Data is always changing. You'll have new data sources coming in, and within existing data sources, you could have new tables coming in, new columns coming in existing tables. All of this, your design should be able to handle that without falling apart each time a new thing comes in. Let me explain with an example. So previously we saw that use case about the report recommender. We are using Power BI REST APIs there. Now, Power BI REST APIs is completely managed by Microsoft. Today, it might return results in a particular format, in a particular order, the attributes in a particular order. Tomorrow the order might change. Of course, if an attribute that you use, if it is no longer coming through, yes, I understand, we might have to bring in some mechanism to handle that. But let's say if the order just changes, your pipeline should not fail because of that. Or if a new attribute comes in, say report runtime or something like that, it should not fail. We should be building in a design such that we are able to take only the information that we need rather than relying on in which order it is coming through. Similarly, in the same example itself, we saw how adding annotations, notes from the users to the LLM was adding a lot of value because we were able to see related to how actually users were using the report. Let's say there's another information that we need to add to it, some additional extra metadata that will give more context to the underlying report. So we should be able to do it seamlessly. We should not be rewriting the interface that we have set up to the LLM just because we are adding additional data. So your interface, your design should be able to handle these. The last principle I have here, but still a key one, and something that we have mentioned multiple times today, optionality and avoiding vendor lock-in. The AI ecosystem is constantly changing. You have new models coming every now and then, and each time with better capabilities. So we should not be locked into a particular vendor. And one way of doing that is by ensuring we use open formats like Parquet, Delta, and Iceberg. So this just allows us to, in case if you're switching to different vendors, it avoids costly migrations in ensuring we have to change formats. At the same time, we have to be conscious where we are using proprietary formats as well. Yeah. So choose open formats where possible and be conscious where proprietary formats are being used. I went in, but I want to highlight another point here. So we talked a lot about scalability, using metadata-based ingestion frameworks, etc. Now, to build out a quick and dirty proof of concept might seem cheap. But then even if you have to productionize that single, let's say if you're running it for, you're building it out for just one geography or one category, if you want to productionize it, you still need to implement functionalities like auditing, logging, data quality, because that's what makes it a productionized pipeline. Now, instead of doing it that way, if you were to bring in a metadata-based ingestion framework right at the beginning, the delta in effort is not going to be significantly more. But then the benefits that you get, so even though you might not have any intention to, say, roll it out to other geographies or other categories at the beginning, even if down the line, if you decide to move it out to one additional geography or one additional category, there's a lot of savings in effort that you get by using the right approach the first time itself. So with that thought, I want to move to the next one now. So we looked at the engineering side, like how we can use how we have to build pipelines that can scale, be able to handle changes in requirements efficiently. But there's just one side of the coin. The other side is ensuring we have accurate, reliable, and trusted data. That is where data governance comes in. Let's look at some key data governance principles. Where did the data come from? We need to know where the data came from, not just the original source, but through all the steps, the different transformations that has been through. Whether it's an internal system, a vendor file, or a third-party API, understanding lineage is key to establishing trust. Tomorrow, if someone questions a particular result from your AI solution, we should be able to trace it back. Most modern platforms support automated lineage tracking now. So we don't have to rely on manual effort. So tools like Unity Catalog in Databricks makes this much more easier, giving us clear visibility into how data flows through pipelines and transformations. Can we trust the input? Data going to our models has to be reliable. So things like missing fields, duplicates, outdated records, they may not break your pipeline, but they can quietly damage the output. And what is the solution? Many platforms have rule-based and automated data quality checks built in, like Unity Catalog has data quality features, and there are other data quality frameworks like Great Expectations, which you can easily integrate into your existing pipelines. Think of it like a checklist that is triggered each time a data load is run. So it will go through a list of checks null detection, threshold validation, to see if the delta is beyond a particular threshold, referential integrity, if there is any missing referential integrities, outlier detection, and so on. Next, who can use what data for what purpose? Not all data is for everyone, whether it is PII, personally identifiable information, financials, or regulated content. We need clear policies on who can access what data and for what purpose. At a healthcare company, for their management reporting, there was a clear need to ensure that the confidential patient information was not getting into the gold layer. So we implemented techniques like we masked the patient information by using techniques like tokenization, wherein we randomly we replace the patient information with random tokens, so that it was only anonymized information that was going into the gold layer. Finally, do we even know what we have? So this is kind of similar to the problem that we had with reports. If you have a large number of reports, when a user wants to get to a report, are they able to reach the right report? The same thing with data. If you do not know what is there, you run into the risk of duplicating, maintaining different copies of data. And this is a common problem. This is what we have seen at a customer as well. They had different silos, and in each of the silos, there were different copies of the same data. And the problem was, in some silos, the data was quite up to date, but in others, it was a week old, it was a month old. And imagine, if we have to use this data for our processes, how much of a risk it is, how much it impacts the reliability of your output. So this is where data catalogs like Unity Catalog, Azure Purview, AWS Glue Data Catalog, they make things much more easier. So they let us browse, search, and tag datasets across the organization with ownership, description, and usage metrics, and lineage all in one place. This makes it easier to collaborate and use trusted data consistently. So to end, when we combine good data engineering with solid data governance, we are setting ourselves up for true AI success, where the right people get the right data and everyone can trust the results. To bring it all together, AI success is not just about having the right model. It needs the right data, clean, reliable, and well prepared. It needs to be built on right engineering principles, pipelines that can scale, handle new requirement, and keep things running smoothly. And it needs governance, so everyone knows where the data came from, that it can be trusted, and who can use it. It's not included here, but equally important is being aware of the ethical considerations of each choice you make at all stages. It is all of these together that make AI real, usable, and sustainable. With that note, I'll hand it over to Brendan, who has an interesting business case to share. Build on the same solid data engineering and data governance principles that we discussed today.